All right, take a look at your homework handouts. Homework handouts out should look like this, except it should be finished instead of empty and blank like mine. Hold your handouts up so that I can see that you completed the work that I didst assign for Sooth. All right, and at the top of the page, of course, it says rationalize the denominator. And what does it mean to rationalize a denominator, Michael? Good, it means to make it rational. What does it mean to make the denominator rational, Michael?
Rationalize it.
No, Michael. This is a two-step answer.
Circular reasoning. It means yeah, you're going to have to explain it for me.
To take the root of the denominator.
That thing.
That thing, yes, the thing. To take the root of the denominator. So we have to take the root, right? And on the first one, we have to take the square root of what, class?
5m.
5m, but you can't. So, what do we do, Kendall?
You could take this. Oh, you could turn into a square root of 25m squared.
I could turn it into a square root of 25m squared. How?
Multiplying it by 5. No, the square root of 5m.
Good. If I multiply the square root of 5m by another square root of 5, then of course what I do to the bottom. So I'm also going to multiply the top by the square root of 5m to get
2a times the square root of 5m.
Good. Not 10am, the 2a times the square root of 5m. And then from here, we do what we set out to do in the first place. Take the root of the denominator. It's what rationalizing means, or to make it rational means. And so our final answer here, Kendall.
2a times the square root of 5m over 5m.
And there we go. How many had this answer on the first one? On numero dos, we have a 3x over the cube root of 16x. And we have to take the root, but we can't take the root. So Maddie, what do? Multiply top and bottom by the cube root of 4x squared so that my denominator becomes something I can take the root of. 64x cubed. Of course, the numerator. Right, remember you said squared, not cubed. The radical doesn't mix with this, they just stay together. And now I'm able to take the root. And so what's my answer? But of course, I'm not going to leave my answer like that because there's one more little thing we can take care of. I can cancel the x's, but when I cancel away a variable, class, I need to specify that that variable cannot equal 0. And that's the last little detail. When it's a variable that cancels out, since that variable is still in the problem somewhere, we'll set that unequal to 0, and now we're good to go. Other than maybe the x can't equal 0, how many had the right answer? Did anyone think to put x cannot equal 0? Okay, I was going to say show off, because I've never had a student remember that on this point, just because we've kind of moved past fractions. But that's a dangerous thing, considering on Thursday's test, we have fractions. All right, let's go to the next one. We have a 1 over the 4th root of x cubed y z to the 6th. And Michael, what doth we needeth to do?
You need to rationalize it.
We do. By doing what?
Making it rational.
By doing what?
Multiplying it by x. Y.
Well, we'll make it rational by taking the root. How do I take the root?
You multiply the bottom by this 4th root of x, y to the 3rd, z to the 2nd.
Good. So that my denominator now becomes the 4th root of
x to the 4th, y to the 4th, z to the 8th.
There we go. And my numerator is still a 1?
No.
No. Of course not. It's foolish to even suggest it. What do?
You multiply it by the 4th root of x, y to the cube, z to the squared.
Y to the cube and z to the squared. Okay, and what do we get when we multiply that by 1?
You get the 4th root of x, y cubed, z squared.
And now I'm able to take the root of the denominator. I'm able to rationalize to get what final answer?
The 4th root of x, y to the cube, z squared. X, y, z squared.
Can I cancel the x's, class?
No.
What about the z squareds?
No.
No, nothing cancels. Just that. How many have this answer? 4, the first one, the second row. Questions on that? Let's take a look at numero quattro, where we had a 5 over the cube root of a squared bc cubed. Genesis, what do we need to do?
Multiply the bottom by the cube root of ABC.
Multiply the bottom by the cube root of a, b, c, so that the denominator becomes what?
Cube root of a cubed b squared c to the fourth.
Now 3 can go into 3, right? So I want that. Can 3 go into 2? No. So that 2 really doesn't do me a lot of good. I really need that to also be a cube, right? But to get a cube there, I would need to multiply not the b by another b, but the b by a b squared. And then the c to the fourth, well, 3 doesn't go into 4, but it could have gone into the original cube, couldn't it? So do I really need the extra c? No, so let's take that c off. Well, let's take it off of here, so I'm still left with the c cubed. Does that make sense? So it's not just multiplying by whatever letters I've got, but it's multiplying strategically by just enough letters to make it where I can take the root. Of course, what we do to the bottom. So I'm also going to multiply the top by the, to get what in my numerator?
5 times the cube root of AB squared.
And now what?
The numerator stays the same. And it's the cube root of AB.
The cube root of a cubed, b cubed, c cubed becomes what?
Cube root
How many times is 3 going to 3?
of, just ABC.
A, and then B, and then C, and nothing left inside the cube root except, I mean, if you want to say there's technically a 1 left in there, but man, we don't really need to keep the cube root once we've taken the cube root. And that's kind of the point, to get that radical out of the denominator. How many have that answer for the fourth one? Questions on that? All right, let's take a look at the next one where we had 2 times the square root of 5 over the square root of 7. You could read this as a division problem. Really, the process doesn't change much. If you read it as a division problem, you say 2 divided by 1 is 2. 5 divided by 7 you can't do, so treat it like 5 sevenths. And then, class, you'd multiply top and bottom by 7s to get 2 times the square root of 35 49ths, where you can't take the square root of 35, so you get 2 over 1, square root of 35 over 7, and since nothing cancels, we leave it all like this. You'll get the same answer if you treat it as a rationalization problem. If you say, I don't worry anything about the numerator. Right there, I've got to take the square root of 7. But I can't. So class, I can multiply top and bottom by square root of 7 to get still 2 times the square root of 35. And here's where we could save ourselves a little time. We know that's going to be the square root of 49, right? And we know the square root of 49 is, let's not waste our time. Let's just go straight to that. Okay, so either way you approach it, same answer. How many got that answer on this one here? Good questions. Looking at the next one and coming over to Abby. Is this one you missed?
I don't think so.
Coming over to Abby, we have the square root of a minus c over the square root of a plus c. But I can't take the square root of a plus c. But I could take the square root of
A squared plus C squared.
class
A plus c squared.
a plus c squared, which is not the same as a squared plus c squared, right? Because when you square a binomial, you get square the first, square the last, multiply and double. So, no, but if I could get down here the square root of a plus c quantity squared, then I could take the square root and I just get a denominator of
A plus C.
a plus c. But to get that, what I do to the bottom, I got to do the top. So how do I go from a square root of a plus c to a square root of a plus c squared?
Multiplied by A plus C.
Or technically the square root of a plus c, right? And what we do to the bottom,
You have to do the top.
so we're going to multiply with the square root of a plus c here, and I'm going to take the square root of a minus c times the square root of a plus c. What do I get?
A squared minus C squared.
The square root of a squared minus c squared. Can I take the square root of that? No, because again, you only take the root of factors, not terms, and these are individual terms. So we're going to have to leave the square root of a squared minus c squared all over the a plus c, and that's our answer. Did anyone get this answer on this one here? Good, several of you. Those who didn't, does it make sense now with the polynomial? Questions on that with that polynomial in there? We don't see a lot of those. It's the only one on the handout, obviously, but questions on it? All right, let's move on to the next one. And Brandon, we have an ABC over the square root of a to the fourth BC cubed. What do we need to do?
Multiply both top and bottom by square root of BC.
To get what initial fraction?
And the numerator ABC on square root of BC. And then the bottom square root of a to the fourth, b to the fourth, and c to the fourth.
Is it a to the fourth, b to the fourth, c to the fourth?
No, b squared.
There we go, a to the fourth, b squared, c to the fourth. Okay, Frank, continue.
And then you can factor the denominator.
Not factor, just take the root, right? So what is the square root of a to the fourth, b squared, c to the fourth?
A squared, b, c squared.
There we go. And of course in the numerator we still have a, b, c times the square root of bc. But we're not finished yet, Brandon. Right, I can cancel the a's and I'm left with in the denominator. I can cancel the b's, no b's left, right? Cancel the c's.
One c in the denominator.
So what's our answer?
Square root of bc over ac, where b can't be 0.
There we go. The a is still in the denominator, so I don't need to specify that it can't be 0, though it's not wrong to. I don't have to specify that c can't be 0. It's just the b that has to be specified here. How many, whether or not you had the b can't equal 0, had the correct answer otherwise? All right, how many, even before he said it, you realized because of the earlier problem, oh yeah, I'm going to need to set the b unequal to 0? You also thought of that, as did Brandon? Questions on this problem? Questions? All right, Audrey, we'll give you the last one. We've got an xy over the cube root of xy squared. And walk you through.
You multiply it by the square root of x squared y. And you do the same to the top.
Like that cube root, technically, of x squared y.
And you get the cube root of x cubed y cubed.
Which, of course, I know is just going to be
xy.
xy. And then rather than take the time to write here and here, let's just go straight down here to get
xy times the cube root of x squared y. And then you can cancel the xy. So you're left with the cube root of x squared y, where x and y can't equal 0.
And there's our answer. Other than the x and y not equaling 0, how many had that answer? All right, questions? All right, go ahead and set that aside if you would, please. Next section in your notes. Next section in your notes, and it's kind of a continuation of where we left off yesterday. With all of these denominators, they were single-term radicals, meaning there wasn't anything with the radical in the denominator. But for instance, what if I had something like this, 2 over 1 plus the square root of 3? Well, here I have what I call a two-term radical denominator. I call it this because the denominator has two terms, and there's a radical in one of them. I call it two-term radical denominator. I'm not particularly creative. But when it comes to rationalizing a two-term radical denominator, that's the next section in your notes, we still have to take the root, right? But I can't take the square root of 3. So maybe, class, I could take the square root of 9. And so to get the square root of 9, I just multiply top and bottom by square root of 3, right? And don't write this down. In the top, I end up with a 2 times the square root of 3. And on the bottom, you realize the square root of 3 has to be multiplied by the entire group, right? There's not parentheses, but the fraction bar is a grouping symbol, so I'd have to distribute, wouldn't I? And so that would give me the square root of 3 plus the square root of 9, where I know the square root of 9, class, is 3, and I've rationalized part of it, and I made the other part irrational. You see how this would be a vicious cycle, right? If I multiply by another square root of 3, it's not going to work, is it? So maybe what's another thought besides, well, multiplying by the square root of 3? Well, if I just had a square root in the bottom, maybe if I could square the top and bottom, right? So if I square the top and I square the bottom, square the top to get, class, 4, don't write this down. If I square the bottom, square the first, square the last. When you square a square root, you get the radicand. So when I square the last, I just get, do you see there? Rationalizing. And then multiply and double. Still a radical in the denominator. If only I didn't have to multiply and double, because I was doing pretty good, like with just squaring the first and squaring the last. It's that multiply and double that screws it up. Square the first, square the last. Don't multiply and double? Kind of. Square the first, square the last. If I put a minus sign, that wouldn't give me the multiply and double term, right? So what we're going to do instead, and this is where I do want you to write this down in your notes, if you have a two-term radical denominator, the thing that's going to clear it out, you're not going to be able to manipulate the radical to give you something you can take the root of. But what you can do is if you multiply by the conjugate to artificially make a sum and difference here, yes, there's still going to be a radical in the numerator. I don't care about the numerator. It's like, the next door neighbor's kid. I don't care about them. It's my kid I care about, The dog on the loose, get my kid inside. Neighbor's kid, he can fend for himself. Okay, I'm just kidding. No, I care about the denominator, right? And if I multiply by the conjugate, I'll square the first, still 1. Square the last, still 3. Just put the minus sign between them. And now the radical's gone. So with the two-term radical denominator, here's the key. Multiply by the conjugate. Multiply by the conjugate. Of course, what we do to the bottom, we have to do to the top, and it's all about the denominator. So I've had students ask, do I do the conjugate of the top or the bottom? Which one do we care about? The bottom? Then do the conjugate of the bottom, right? So multiply by the conjugate of the denominator, do so in the numerator and denominator. It's what we do to the bottom, got to do to the top. And then from here, I can actually simplify the denominator even a little bit more, right? 1 minus 3 or 1 negative 3 class? Negative 2. And I can even divide a little bit here. And divide a little bit here. What's 2 divided by negative 2? And what's negative 2 square root of 3 divided by negative 2? Positive 1 square root of 3, or just positive square root of 3. And I end up with something that isn't even a fraction now. But I definitely don't have a radical denominator anymore either. Questions on this? How many remember learning this in Algebra 1? Multiplication by the conjugate. Okay, not any of you remember that. All right, we did do it. It's just been a very long time. All right, so we'll spend a little bit extra time here today making sure we're good to go with this final concept. All right, write this down in your notes if you would. 5x over the square root of 2 plus the square root of x. Notice how many terms in the denominator, class? 2, and at least one of them, in this case both of them, are radicals, right? There's at least one radical. So we have what I call a two-term radical denominator. And to get rid of the radicals out of the two-term radical denominator, class, we need to multiply by the
Conjugates.
Well, conjugate, singular. And so the conjugate of square root of 2 plus square root of x, class, would be
Square root of 2 minus square root of x.
square root of 2 minus square root of x. But what I do to the bottom? So the top also gets multiplied by the square root of 2 minus the square root of x. In the top, I've got a monomial times a binomial. How could I multiply that? Distribution, right? I could distribute. Or, in fractions, oftentimes I factor anyway, right? It wouldn't be such a bad thing to leave the factors showing, because in order to reduce, we oftentimes need to factor anyway. Does that make sense? Just a strategy tip. Rather than multiplying them out, maybe leaving the monomial undistributed. Would it be wrong to say 5x times the square root of 2 minus 5x times the square root of x? No, either one's fine. And in this one, we're not going to be able to reduce anything anyway, so it's definitely not a problem, but, All right, what about the denominator, though? In the denominator, I've multiplied by the conjugate to create what special case, class? Sum and difference. And when I multiply sum and difference, 3 steps. Thank you, Brandon. Class, what do I do to multiply sum and difference? Square the first, square the last, put a minus sign. So what is my denominator going to become, Genesis?
Square root of.
Well, when I square the first, I'm squaring a square root. And when I square a square root, I get the... So I just get 2 when I square the last. And then I put a minus sign. And there's my answer. Or you could have the other numerator. We're done. Questions on this one? Write this one down. Square root of 7 plus the square root of 3 over the square root of 7 minus the square root of 3. Oh, so tempting to cancel the square roots of 7 and the square roots of 3, but we can only cancel factors. We can never cancel terms. Furthermore, I have a 2-term radical denominator. What am I supposed to do when I see a 2-term radical denominator, Maddie? I'm glad you didn't say cry. No, multiply by the conjugate. And what is the conjugate, Maddie? And what we do to the bottom, class? Make sure you multiply the exact same thing, top and bottom. I've seen some kid try to be like, multiply the conjugate of the bottom and then a different the conjugate of the new. No. Same thing, top and bottom, right? You're multiplying by 1 technically. In the denominator, I have conjugates. Sum and difference. Square the first, square the last. Put a minus sign. Class, when I square the first?
7.
When I square the last?
3.
And then I put a...
Minus 7.
And my denominator really just becomes the number 4. That was easy. In the top, you could argue we have a binomial squared, couldn't you? And you could square the first, square the last, multiply and double if you wanted to, or you could FOIL it. Either one's fine. But if I square the first, class,
7.
if I square the last,
3.
always going to get a positive when I square. And then I'm going to multiply and double. Now be careful here. 1 times 1 doubled,
2.
square root of 7 times square root of 3.
Square root of 2.
And remember, you don't double the radicand. A double means times plain old 2. And we keep the sign, the positive. I can then simplify just a little bit. The 7 and the 3 add together, class, to get 10. So I end up with 10 plus 2 times the square root of 21 all over 4. Now, let's suppose we say, I don't like that. I just want to FOIL. Okay, when you multiply the first, what do you get, class? Square root of 49, which is 7. When I multiply the outers, I get square root of 21. Careful. When I multiply the inner, square root of 21. And when I multiply the last, square root of 9, which is 3. I still get 10 plus 2 times the square root of 21. But I'm not done yet. What could factor out of the numerator that could cancel with the denominator? Class?
2.
A 2. Now, strategy tip. Okay, we're lazy, right? I could factor out a 2, agreed? And then I could cancel the 2, correct? Or there's a shortcut. If you realize that every single term in a fraction has a 2 that could be factored out and canceled, the shortcut is just take the 2 out of every term individually. We're not actually canceling terms, we're canceling the factor out of the terms, but if I knock a 2 out of everything, class, I end up with
5
plus
square root of 21
all over
2.
2. Mathematically, it works the same, and I'm too lazy to write 2 times the quantity, 5 plus square root of 20, and then cancel the 2 and the 4 to get a 1. It's quicker that way. All right? Questions on that problem? How many say, I think I got it, I want to try some of these on my own? How many say, I'm moderately terrified, I don't think I got it? How many are somewhere in between moderately terrified and confident? All right, we'll try one on our own anyway. All right, do this one then. Okay, since no one's abjectly terrified, remembering you do have to do this on a test on Thursday, I want you to do this one. 4 over the square root of 7 plus 3. 4 over the square root of 7 plus 3. Let's see if we should be terrified or if we should be confident. Make a horror movie about math class. The radical denominator. A sight is so frightening. I don't think it would live up to the hype. It's Abby's birthday, and Abby asked if she could answer lots of questions today. Oh, you said you didn't want to answer any questions. Oh, sorry. Well, anyway, Abby, why don't you help us with this one here? What do we do?
We multiply both by the square root of 7 and negative 3.
All right, to get what?
4 times the square root of 7, negative 12.
over 7 negative 9.
Good. By the way, when you square a square root, you get the radicand. This isn't just square root of 3. It's just a plain old 3 squared to get 9. Good job. We can't combine anything in the top and in the bottom.
That equals negative 2.
And here, because it's a monomial, could I cancel a 2 everywhere? Yes, but I like the idea of dividing the negative 2 in each case to get what?
Negative 2 times the square root of 7, positive 6.
And there's our answer there. Okay, you could have pulled the negative out front, right, because it was the sign of the whole denominator. And you could have canceled a 2 out of everything and got negative 2 squared of 7 minus 6 over 1. Now, quick word of caution. I've seen students do this. I'm like, oh, then it's just that. Careful. If you take that fraction bar off, you have to put a different grouping symbol, because that's the fraction bar was grouping. So you could do negative 2 squared of 7 minus 6 if you did it that way, which is the same thing, right? Just with the negative distributed down there. But anyway, did want to caution you on that because I've seen students mess that up. But remember, a fraction bar is also a grouping symbol. So if you take it away, replace with parentheses, especially if there's a negative floating out front. All right, how many got one of these answers on this problem? Okay, a few of you did. Good, good. All right, let's try another one. This time we're going to go binomial top, binomial bottom. So let's see how we do with this one. Square root of 3 plus 2 squared of 5 over 3 squared of 3 plus square root of 5. A zipper of a jacket along a handrail. That's my guess. Compared to nails on chalkboard, not as bad. These chalkboards don't tend to have that awful noise like the metallic ones upstairs. The one in my room does. That one can be bad. All right, Kendall, what do we do?
Multiply top and bottom by negative 3 times square root and then minus square root of 5.
All right, so in the denominator, what do I do?
Square root first.
Now, careful, there's 2 parts to square here. I got to square the 3.
9.
And I've got to square the square root of 3. 3, because I get the radicand. And then I'm going to square the last, which is just square root of 5.
5.
And then I'm going to put the,
Minus 5.
we can do this in our head. 9 times 3 minus a 5 basically becomes
22.
Well, okay, I was asking Kendall, but yes, 22 is correct. All right, Kendall, in the numerator, first, outer, inner, last, right? When I multiply the first, what do I get?
3 times the square root of 9.
Which becomes,
3.
which becomes
9.
9, okay? Then the outer,
Negative square root of 15.
the inner,
6 times the square root of 15.
and the last,
Negative 2 times the square root of 25.
which becomes,
5.
negative 10. All right, so what's our numerator become?
Negative 1. Times 7 times square root.
Careful, negative 1, positive 6.
5 times square root of 15.
And I'm going to put the 5 squared of 15 before the negative 1 so I don't have a leading negative all over 22. And just ignore this doesn't exist. You just think it does. How many got that answer? Anyone have the negative 1 plus 5 squared of 15 all over 22, and you say, well, I got to factor out the negative, and then slide the negative down front, and then leave it like this. Right? Nothing wrong with that at all. It's just more work and I'm lazy. Questions on this? Any questions? How many say, I think I've got it now? I think I've figured it out now. A little more confidence. All right? Let me give you a couple to work this time on your own then. 7 over the square root of 3 plus 2 times the square root of 5. 2 minus the square root of 2 over 5 minus 3 times the square root of 2. I'll give you a third one just for fun. You weren't confident, right? Okay. So, negative to the front. Here's the number. That's it. Okay, don't be scared of that. last one's kind of ugly, but you know, whatever. All right, for sake of time, pencils down. Even if you're not finished with all of them, check your work. On the first one, did you multiply top and bottom by square root of 3 minus 2 square root of 5? And multiply by the conjugate. All right, in the denominator square, the first to get 3, square the last to get 4 times 5, which is 20. 3 minus 20 is negative 17. In the top, we just distribute or leave it in the factored form. I chose to distribute. Doesn't really matter which way you go there. I did move the negative out front, so that way the denominator wasn't negative. How many got this answer on the first one? Questions? Anyone just leave the negative in the 17, just forgot to slide it out? Any questions at all? Looking at the second one, how many multiplied by 5 plus 3 squared root of 2? 5 plus 3 squared root of 2. So in the bottom, square the first to get 25, square the last to get 9 and 2. When you square the square root, you get the radicand, which is 18. 25 minus 18 gives me 7. In the top, I FOILed, got 10, 6 squared root, 6 squared root of 2, negative 5 squared root of 2, and negative 3 squared root of 4, which is negative 3 times 2 or negative 6. Combine to get 4, combine to get positive 1 squared root of 2. Nothing factors, cancels, anything like that. We're just done. How many got that answer on the second one? Questions on the second one?
I just copied wrong.
Okay. All right, and then on the last one, this is really obnoxious because here you have similar binomials. Here you have a distribution. Here, these are not similar at all. I mean, there's nothing similar about these, but you can still FOIL. First, outer, inner, last. This is nothing combines. Math purists would argue, put all of the non-radical values first, then follow with radicals at the tail end. All over 4 minus y. I'm not going to be that picky in high school, but I do think this answer looks better, having the radicals shifted to the back. Either answer is fine, though. How many got that answer on the last one? Again, multiplied by the conjugate, 2 minus square root of y, square the first to get 4, square the last to get y, put a minus sign, and then, like I said, FOIL at the top. Questions on that last one? Any questions? All right, 2 more. Write this one down if you would. 3 times the square root of 3 minus 2 times the square root of 2 over 4 times the square root of 2 plus 6 times the square root of 3. And then, got another one for you when you finish that. When you finish the first one, take a moment to check your work. Any questions on that first one before you go on? I tried to show every step so you could see exactly what I did. Are there any questions on the first one? How many got it before you checked? You had it all good to go before you checked. How many, maybe there was one or two little things you had to fix after you checked? We understand those one or two little things though? All right, good. Do we think we'll be able to think of those little things on our own on Thursday, now that we've seen them? That is the question. That's the key, right? Is you thinking of them yourselves, right? The brain training. And questions on the second one. Again, math purists would say move the 60 up here so that way the radical term is at the end. I don't really care too much. Just kind of leave it more in the FOIL format. But how many had that answer already before you checked it? All right. How many say I didn't quite get that, but I see what I did now? Any questions at all on that? Any questions at all on rationalizing a two-term radical denominator? All right, homework this evening. I'm going to give you some practice with rationalizing regular denominators as well, but certainly the two-term radical denominators, and then also a little bit more practice with radicals. Don't forget, though, the test on Thursday, coming up in lesson 36 for my YouTubers. Gavin and Brecken, we were saying earlier today that we loved you and cared about you. Stuff like that there. It sounded good at the time. All right, Michael's like, lies, all lies. Anyway, but don't forget fractions are a part of this. So if you need to go back through your notes tonight, you might not want to wait till Wednesday night to do all of your study. You may want to go back, look through the notes. Okay, this is the steps. Here are the example problems he did. You know, maybe go back in the book and look at some of their examples in their notes, though I think mine are better, but you know, that's just conceit and arrogance. Page 55. Hey, at least I'm honest about it, right? Maybe conceited and arrogant, but I'm honest. I don't know if that makes up for it. Page 55, numbers 47 to 53. Page 55, numbers 47 to 53. And on pages 66 to 67. Pages 66 to 67, do the review 9 through 20. Review 9 through 20. Should give you a pretty good, for the most part, an overall review of radicals. So that way my goal tomorrow is to focus on fractions again. Okay, the homework is going to review the radicals for the most part. My goal tomorrow is to focus on the fractions, those rational expressions, so that way we can remember all of that too, because I feel like we should be pretty fresh with radicals. Okay, so tomorrow, the focus, lesson 35, the focus is going to be as much as I can on fractions, and then lesson 36 is our test over fractions and roots. All right, have a wonderful rest of your day. When the bell rings, you'll be dismissed.